if you have finished all the activities from last class and the class before, we're going to summarize what I hope you would have gotten out of it, okay? What you have learned from those activities. If you haven't finished them yet, you can just follow along, take your notes, and then when you finish the activities, come back and reread this and make sure it makes sense, okay? So if we have f of x is a basic parent function, okay, and g of x is going to be a times f of b times x plus c plus d. So a, b, c, and d are just numbers, right? Which of those constants move the function, like shift the function up, down, left, or right? C, yep. Any others move the function? D, because D is going to be a vertical shift up and down, right? C and D are both shifting constants. Those two things will move the function. C moves it left and right. D will move it up and down. All right, which constants change the shape of the function, as in stretching or shrinking it? B and A. A is going to change the shape by vertically stretching or shrinking. B is going to change the shape by horizontally stretching or shrinking. Okay, which of the constants affect the graph horizontally, right? Whether it's by shifting or changing shape. C and F is the name of the function. Yeah, so the constants are A, B, C, and D. Yeah. So C is going to shift it horizontally. What else changes it horizontally? B. B is a horizontal stretch or a shrink. So it's B and C change things horizontally, whether it's by a shift or a stretch or a shrink. Which of the constants affects the graph vertically, either by moving it up and down or by stretching it vertically? A and D. Okay. So we want to compare the effects of constants that change the graph horizontally to those that change the graph vertically. So vertically, we're A and D, right? So those things change the graph exactly as you'd expect, right? D shifts it up and down, and when D is positive, it goes up, and when D is negative, it goes down. And A stretches or shrinks things vertically. When A is a big number, it stretches, and when A is a small number, like a fraction, it shrinks, okay? So when you have vertical changes, like A and D, the graph changes exactly as you expect. We'll say intuitively. Intuitively. Exactly as you expect. But horizontally, what have you found about horizontal changes to the graph? They're liars, yeah. So when you make changes to B and C, they do the opposite of what you think they're going to do. It's counterintuitive, right? So C shifts it left and right, but it goes left when C is positive and right when C is negative, right? So it does the opposite of what you think. And B is causes vertical stretching and shrinking, but when B is a big number, the graph shrinks. Shrinks. When B is a big number, the graph shrinks horizontally, and when B is small, like a half, like a fraction, when B is small, the graph stretches. Okay, so the horizontal constants, B and C, the graph changes counterintuitively. Counter to what you would expect. As you work through the activities, they're supposed to help you understand why that happens. But this is just the conclusion from all the activities. We saw that happens, and hopefully you've seen why it happens. All right, so to do transformations, if you want to do multiple transformations, you have to always first change the shape of the graph. That is, do any stretching and shrinking first, whether it's vertically and horizontally. It doesn't matter which. vertical stretching and shrinking, vertical and horizontal stretching and shrinking comes first. Okay, then shift it or move it. Okay, that's the only important thing that has to do with the order. First change the shape, then shift or move the graph. Okay. Now, your book and my math lab will give you different directions for how to do multiple transformations. Use the order that we presented in class. It will better prepare you for the next course you're going to take. And the two methods are actually equivalent, and ours just requires the function to be in factored form, the input of the function. So your book would just distribute this b, which makes a different procedure. Okay, so it's equivalent, but you have to think about it a little bit differently. So I would just say use the factored out b, right, and change the shape before the shifting. And that's all. That's all you got to remember. Okay, so that is our conclusion about transformations. And I want you to now pick up wherever you left off. Whatever activity you were last working on, that's where you should start now.